Okay, so I just got introduced, so I'm not going to repeat everything, but basically I'm a staff Node.js core engineer and also developer experience engineer in NearForm. You can find me on Twitter and on GitHub on these handles, and that's where I come from, the little dot in the middle of nowhere. I mean, whatever. Okay, so let's get started. First of all, let's shout out for GraphQL, because we use it every day. It's a technology that has made our lives much, much easier to deal with every day. And the thing is what we exactly got from GraphQL. Now, we can get many resources with less overhead in an expressive language that is very easy to translate, whether in TypeScript or whatever we want, on Prisma definition, I mean, anything. A very another thing that we have is no overfetching nor underfetching. We just get the data that we ask for. The server cannot pollute us with many things. Pay attention to this, because this will return a lot. And one nice thing that we have is that we have federation, or stitching, which is the opposite operation, right? In which we can, basically, we can join multiple schema, or we can split schema in two different services. And this is great for separation of concerns. The idea behind GraphQL Federation is that we split the schema in subgraphs, and so each service is just responsible for one area of the graph, and we obviously can integrate with either local or remote services. There is only one downside with just raw federation, that we have to use GraphQL anywhere. That's the problem. We can't directly integrate with the REST API. Of course, we are developers, we can do almost everything, but out of the box, we can't. We have to use GraphQL everywhere if we want to, which is not a bad thing in a way. There is only one thing to consider. The server knows better. It's very easy to attach new resources to a server, and the problem arises when we have to push these changes to the client. How do we do that? How we can push this data to a client that has not asked for this data and doesn't even know that this data exists? Which basically be, how can we be proactive? Now, in the future of this talk, I will talk about one technique that I'll call data enriching, which I'm not spoiling anything at the moment. But for now, let's start with a very easy case. The happy case. We are in control of everything, which is our bad dream as developers. We think that we can control the entire environment, right? So in that case, what we can do, add new data to the server schema. That's the first. Verify that clients are still working. I mean, double check. We know that we should double check. We should do unit testing, integration testing. We should do everything, right? So we have to check where we haven't broken backwards compatibility between client and the server when modifying the schema. So, which means that basically our modifications to the schema should, in theory, be additive. We can add new fields, we can add new types, but we cannot change the previous one. When we're done with it and no client has been broken, we update the clients. That's it. We update the queries in the client, we use the new data. That's it. Thank Prisma for hosting me. That right? Thank you. Actually, Fox, you already know the answers. We are not done yet, because that's not the truth. This happy case is mostly theoretical. First of all, you have to be in control of the clients. You have to be able to force the client to upgrade in either a very nasty way, saying you can't use the application unless you click on update on the App Store, or you can, I don't know, if it's a service, if it's a web application, you can download using service workers, but you have to take account of this, because people might never refresh your page. If you think about this, of course, you can immediately realize that nothing can go out of sight, because if one component, even in the best case possible, is not updated at the right time, compatibility problems will arise. Now, we all know that in the client side, people are very spoiled about having a response time between 100 milliseconds. So if we get to the 500 milliseconds, they get very angry. Think what happens if we actually get an error at all. They see a partial application, anything. Now, going further, since we are on the client mostly talking about JavaScript, which is a dynamic language, right? Even if the client is able to handle the data that they never ask for. Somehow they are able to manage and handle that. There are no errors at all. We are breaking the specification. Now, please repeat after me. Bend. Don't ever do that, please. Okay? Don't. I mean, do we have a choice? Of course. Dark side. We go to the dark path. We break every spec possible. And we leave the company. The company will fail in 3 years after we left because nobody remember what we did. That's one possible case, right? Not nice. We have the happy path. Of course, it's an uphill, so it's going to be difficult. It's not going to be easy, but we can do that. That's why I want to introduce you the GraphQL extensions. Now, we all know that a GraphQL response is made of data and errors. We probably also know that there are also extensions possible in a GraphQL response, but we don't often use them for no apparent reason. I mean, in theory, if we control the server and the client, we don't need extensions for any reason, except maybe for some metadata. But, you know, now, this extensions field is already in the GraphQL spec, is explicitly created for developers, for us to make it in the best way possible, for us to play with them as we want, without worrying about specifications, data, compatibility, anything we want. The very good stuff is that existing clients which are not expecting to receive the extensions, we just ignore them. So nothing bad will happen to old clients. Second note, serialization. I'm not sure how many of you have ever read the GraphQL specification. Okay, I mean the one that I expected actually for some reason. So the thing is that not many of you will know that actually GraphQL does not enforce a serialization format. We can use whatever we want, whether it's protocol buffer, whether it's a gRPC, whether we can do any bad. Actually, I'm not sure whether it's a good thing or bad thing. We can do very horrible thing if we do the wrong way. But okay, same for the network stack. We could technically host a GraphQL server over a telnet connection, or even maybe a DNS connection in hiding the data in the DNS queries. We can do very, very horrible thing. Now, let's face the truth. 99% of the times, and this number is completely arbitrary, so you can replace it with whatever you want, but 99% of the times, we are just talking about GraphQL served in JSON serialization format over HTTP. That's it. And has anybody of you used in any different way ever? Really? Huh? Technically, it's HTTP anyway. Anyway, but I see your point. Over socket is wonderful. It's a very good example. Instead of using, oh, no, nice one. No, actually, no, that's a good thing because I said 100% minus something. I mean, the usual 99999 whatever, right? Absolutely fine. I like it. Another thing I would like to introduce you is something you actually all know. Do you already know JSON path or similar syntaxes? Raise your hand if you know that. Okay. So we all know JQ tool, so we already know how it works. It's a JavaScript-like selection path. I mean, it's way more powerful than what I took when I checked the spec, but in the 99% of the time, again, that's the most that you do. Basically, you just do j.countries, .capital, whatever. The thing is that it's very easy to implement. Even if you, for some reason, don't have an existing implementation in your language, it's very easy to implement. Now, finally, I was talking about enriching. Enriching is a technique that a name that I made, which basically means inject data in the extensions of the response based on the input query. Now, how does it work? Pretty easy. First, we analyze the query. We parse and validate. If we have a request error, that in case of GraphQL means that the client has sent a malformed query, whether it's bad GraphQL syntax or, let's say, wrong types, wrong selection set, and so forth, we just stop there. We don't care about anything else. Then we have to make sure that each selection set has the type name included in it, for a reason that I will explain later. So I have to find a way that I will show in a bit to make sure that each selection set has the type name inside. Then we execute the query on the upstream server. We fetch the additional data according to an handler that will decide whether on the information that we get, if we have to fetch additional data or not, and eventually add to the response. Finally, add this additional data to the response itself, to the response format. That's it, done. With this way, it's very easy to implement a GraphQL proxy that basically, given an input query, will add data in the extension that will not break the GraphQL specification because the data is not in the data section, but is in the extension, so it's free for the client to use. Let's start from the beginning. First of all, we have to ensure that we have types everywhere. So in the input query that you see on the right, the green fields have been added by my algorithm, and I'm using the aliasing technique of GraphQL. Does anybody know what the aliasing is about? Okay. The reason why I'm using the aliasing is because I have to find an easy way to recognize whether type name was originally included in the query, so I don't have to do anything, or I was the one that added that, so I have to remove before returning back to the client. Otherwise, I'm breaking the specification. Remember the pink slide, don't. And that's it. That's pretty much it. One thing that was also present in Dan's and Lauren talks is that cache everything. Even if you're not even executing the query, make sure you cache the query because parsing and validating them is overly expensive. Remember that in case of Node is all CPU, which means that the entire process is blocked while parsing this thing. So cache both the original query and even the enriched query, as I defined that, because reading and then adding these fields is expensive. So since we are doing the same operation over and over again, I mean, even a LRU cache in memory will suffice. The best thing you can do, very easy, that's it. Very easy, very easy to do. One last thing before showing you the code is very briefly explain how a depth-first tree traversal algorithm works. If you have a complex object, a depth-first tree traversal will work starting from the root and going down up there is a leaf node, and then eventually go up until all the siblings of a parent node are visited and so forth. So if you follow my image there, we start from the root, we go all the way left until we stop here at number 4. Then we go one level up and we revisit this part of the tree, 5 and 6. Then eventually go back up to 2, and so that's 7, 8, and 9, and so forth. So that's a way to... the reason why I chose a depth-first traversal for this example, because I will show you it's very easy to implement. Using recursion is going to be very fast. Okay, so this is the main function of the proxy handler, okay? The very important thing that you need to notice at the very beginning here is the following. First of all, as you can see here, I'm not using GraphQL on the server. There is no Apollo, there is no Mercurius, there is nothing. It's just a Fastify server, which could be anything in theory. The second thing, I get the parse, print, and visit from the reference GraphQL implementation in JavaScript, so it's very easy to analyze these, the abstract syntax tree, validate it, and so forth. Actually, I'm not validating because it's just a slimmed down version, but of course you should. So how does it work? On line 12, we parse the document, and we make sure that it's semantically valid. Consider that after parsing, we should also validate it. Then we add the types information with the technique that I showed you earlier to the original query, and we print it on line 19, getting the new query, which is going to be sent to the upstream server. We execute on line 22 if there are errors on the GraphQL queries, which basically was HTTP error, I just return it back. Otherwise, I parse the body, and on line 31, which is the core of the entire idea, I enrich the data got from the server with passing an enriched ID, which is a unique field for all the added types information, and an handler, which in my case is called add weather information. At the end of the day, I return it to the client doing this thing. I first return the original response, so GraphQL response. Then I create the extensions field. Don't forget here, because this might be a side effect, that you not only have to add your extensions, but even the original upstream extensions. Because of course the upstream might choose to return some extension, you want them to come to the client somehow. And that's it. That's the main handler of the entire server. Now, let's go in detail how it works. The enriching types information that I show you in the previous query. Actually, that's very easy to implement because the visit API of GraphQL reference implementation in JavaScript has this very nice API that says, if you are just interested in Behold when I encounter a selection set, just pass me a selection set function with a node. That's it. Now, in the selections of the set, I will check if there is already type name, and if this type name is not already aliased, because it might be that for some reason the client is already asking for a type name with a different alias, so I could not find it in the response. So if the value is type name and it's not an alias, then I already have type name, I can just return. Otherwise, I basically add a new selection to the set, which is basically kind field. The alias is the ID that I'm using all across these requests. The name is type name, obviously, because I'm asking for the type. That's it. When I'm done, I return the updated document, which is still AST, so I have to print it, and the generated injected field. Here, in this example, I use a very stupid generation logic, which you can see on line 6, which is just enrich type underscore timestamp, very, very base case. You can do probably something way better, but whatever. Now, we have to fetch the data eventually. So it starts with the enrich function that gets the data received from the upstream server, then the enriched ID, which is the one that I just generated, and the handler, which I will show you later. And remember that basically is a function that eventually returns extensions to add to the to return to the client. So the idea is that I traverse the entire data returned by the server using a depth-first traversal of the tree, which basically says for each property of value.entries, if it's an array, visit by passing to the new path the index of the array, otherwise you pass the property. That's pretty much it. It's very, as I told you, it's very, very easy to implement. And for each of that, I execute this selection function that says execute the handler either on the value.type name, which is the unaliased type name information, or my enriched ID that I just added. One of the two must be there by the assumption that we have made in the past. Execute the handler. If you get any additional data, add it to the extensions by joining, so basically constructing back the JSON path for the node that we are currently visiting. And that's it. Then, line 36, the core of it, make sure that we remove the enriched ID, because otherwise, once again, we are breaking the spec. That's something you will hear me saying more and more and more unless you don't want to see me anymore. And that's the handler. As you can see, the handler is very easy. In this case, I'm just checking if my type is not a city, I'm not adding anything. Otherwise, I do a very stupid HTTP request and eventually attach to the... I can either return data, so temperature or whatever, or I can return the error. Because remember this thing, technically speaking, this enriching technique should not prevent a successful response got from the upstream server to be returned to the client. So you must be lenient to errors from this logic and say, I have to return something, whether it's an error or it's a data, but I have to return because I cannot prevent the original query to be rejected due to this technique. I mean, you could choose to, but once again, you're breaking the spec. Because the upstream server has been successful, so you have no right to basically prevent it to go back to the client. And that's it. That's the implementation. Now, let's see a very quick example. So, this is the original query that the client has sent to the server. Very easy. Is a country query with some types, some edge nodes, and so forth. As you can see, type name is present here and is present on line 3 as an alias. When we enrich the query, we have something like that. So we have the ID at the very top level. We're not going to use it, but we have it. We have here on line 4, because line 5 used an alias. So technically speaking, we could have tracked it, but it makes overly complicated. So it's probably better to just enrich it like this. Is a simpler approach. And we have here because it was missing at all on line 11 and 13. That's the idea. Now, this is the upstream response. As you can see, it has the enriched type everywhere. and as you can notice from from the response, it's very easy to spot where it was our fault that that field got inserted there, because it's very easy to distinguish. And then this is the final response that is going to be sent to the client. So we have the original query they asked for, and we have the extensions field using JSON path to reference the original point in the query that will show some data. So in this case, we can know that in Abbeville, in somewhere in the US, I guess, the temperature was 19 degrees somewhere in time. And that's it. Now we're done for real. That's the idea. Now, before we go, take-home lessons. First of all, read the specs. They are formal, they're verbose, they are obnoxious, they are very boring, but they contain everything you need, probably. Much smarter people than us already have talked about all the stuff we might need. Otherwise, file a PR to the spec, but read the spec. Be compliant. As I said too many times now, don't break the spec, because the very important thing is that even if the peers are lenient on specification breaks, they might stop at any time. It might be error, might be something that should never happen, so they might fix the error. So don't risk, because you might lose customer, clients, I mean everything you know. Lastly, closely analyze the environment. Even if you develop the experience from the end to end, you do not control everything, because in life you cannot control everything, folks. That's not a real idea. It never happens, and you will never happen. So something bad will happen. So analyze everything and make sure that if you can't really update all the clients, you can't update the schema. Unfortunately, you have to wait. One last thing. You are remembered for the rules you break, which means in a positive side, you will remember for the innovation you bring to the universe. In the bad sense, people 10 years later will remember that you were the one introducing this breaking change, and will chase you. So don't do that. That's it. Because they will remember where you live, and they will come after you. One last thing, I would like to thank NearForm for sending me and Michele here. We have a global remote company, a consultant company based with open source software. We are massive contributors to the open source community, 800 millions downloaded monthly. And we contribute in Node Core and several other projects, including for the GraphQL section, Mercurius, and so forth. So we are always hiring and looking for talented people all around the world. So ping me and Michele if you're interested. That's it. Do you have any question?
Probably a simple question, but there is like already, like for errors, for example, you have already the path in GraphQL, which is basically just the array with the like the keys and the indices in there.
Yeah.
Is there a specific reason why JSON path is preferred as a selector compared to having another property, like the path property from the arrows, basically?
Because with this approach, I'm not starting from the AST of the query. I'm starting from the response, which was something that I forgot to mention in this particular simplification is that this proxy handler that I show you is the app path. So there are no fragments, there are no unions, as you can see, very simple types. When you start introducing fragments, mutability in the possible types and so forth, it becomes really hard to track from the AST. So it's better to start from the final data. That's the reason. That's why starting from the data seems to be counterintuitive, because you're doing the JSON part from scratch, but it makes your life easier to analyze what you get.
Okay, cool. Thank you very much.
What are some use cases where you would use that? Because we use something very similar for caching if we want to proxy something, and we need the type names for constructing a cache key or something like this. What are the other use cases? What are you using it for?
Could possibly be that we solve the same problem, just saying, without knowing each other, which is something, I mean, it's very uncommon in development, right? We might have just resolved the same problem. The thing is that you have to think in a case where you can't the core idea is that you can't aggregate all your clients, so you have to find a way to send both clients the same data, because as I said in the beginning, unless you modify your schema in an additive way, so you never modify existing stuff, which on the long term is going to kill you at some point, because you have too many types and so forth. I mean, it's unmaintained, conflicting, and so you know where we are going, right? So you have to find a way to send additional data to the client without modifying the schema, in order not to affect not up-to-date clients. That's the idea. And another thing that you might consider is that you could even do that unrelated data, saying, to give you an idea, let's say I ask for the application logs in, I ask for my user information, and you want to tell me that my subscription has expired, right? The client is not asking for that specifically. You can put in the extensions, and eventually the app might be configured to eventually look there and see if there are things that are just meant to be, I don't know, shown to the user. I mean, just a text message shown to the user without even analyzing and so forth. That's the core idea. So it's something that you not really tailor your client. I mean, it's slightly a violation of the idea of the GraphQL, right? Where you custom tailor your query. In that case, say, if you send me additional data, I want to receive it without breaking the GraphQL spec.
Could be.
Whether I might using or not.
Yeah, this raises an interesting idea. If you send a subscription, but instead of like subscribing real time, you could just say to the server, okay, I'm interested in the data, and then if you're doing an actual HTTP request, you could include this metadata within there.
Of course, you can use a. Yeah, you might just send an int to the client saying, please ask for this other query. Of course, you can. I mean, this was a very stupid example. Of course, there are plenty of ways to use that. In one reference thing that I was making, there was the one use case was to basically join a GraphQL data with the REST API data in a way that the GraphQL was not, in this case was Apollo, was not complaining about that because the query schema was not modified, but eventually sometime Adobe Target could return some data. So that's why I have to use extension, because otherwise I cannot push this data to the client because I don't even know how the data is shaped, even though I modify the query, because it can change at any time. So what I did, I wrote this thing and injected with the hook on the Apollo client side in order to manage the additional data and rebuild it and do very horrible thing that I don't want to remember now. That's the short idea, pretty much.
Okay, thank you.
No problem.
Anyone else?
All right, thanks, Paolo.
Thank you, folks.